Bismillahirrahmanirrahim. Welcome back in class of elementary number theory by David and Burton. My name is Azmat Ali and I welcome you all in my channel Academy of Mathematical Sciences. Lastly, we discussed question number 4, A and B part. Both questions are related to properties of GCD. In today's lecture, we will discuss its remaining two parts, C and D. These two parts are a bit more difficult than the previous one. So we will solve these two parts with the new techniques. So let us discuss first C part. Given that if GCD of A and B is equal to 1, then we have to show that GCD of A plus B and their sum of square, A square plus B square, is equal to 1 or 2. Firstly, we suppose that the GCD of these two numbers, A plus B and A square B, is equal to D, some positive integer D. Let GCD of A plus B and A square plus B square is equal to D. If D is a GCD of these two numbers, then by definition of GCD, D must divide both of the number. It means D divides A plus B and D also divides A square plus B square. Now consider this expression. Consider expression D divides A square plus B square. I want to complete its square just to involve this expression. By adding and subtracting 2ab, we have D divides A square plus B square plus 2ab minus 2ab. So this can be written as D divides A plus B whole square minus 2ab. As it is given that D divides A plus B, we have a result that if a number, if D, that is the GCD, if D divides some number, then it must be that it will divide its square. So D must divide A plus B whole square. Now, this expression shows that D divides the difference of two numbers, and by using this, D divides one of them, that is A plus B whole square. It must be that D divides also second number, 2ab. You can give reason. D divides here A plus B whole square. It is obvious that if a number divides the difference of two, and it is also given that D divides one of them, then it must be that D divides the second number also. It means D divides 2ab here. Say this is my star. Now the work is hard. Firstly, I will use here problem 20D of question 20D of problem 2.3. What was problem 2.3 here? Problems to question 20D, problems 2.3 says if GCD of A and B is equal to 1 and C is the common divisor of A and B both, such that C divides the sum of A and B, then this problem says the GCD of A and C, GCD of A and C is equal to GCD of B and C, and both are equal to 1. So I will use this property here. It is given that it is given that GCD of A and B is equal to 1. This is given in question. This is given in question. Also, GCD also the GCD sorry also D divides A plus B. This is also from here. Also D divides A plus B. So I can use this property. This property says that if two numbers have their GCD equal to 1, there is a common divisor. D is one of the common divisor. There is a common divisor of both A and B. Then, and if that common divisor divides the sum of both numbers, then it must be that GCD of A with C and GCD of B with C is equal to 1 here. So GCD of AB is equal to 1. D divides the sum of both numbers. This implies GCD of A with D is equal to GCD of B with D, and both GCD are equal to 1. Next, to prove the result, I will use the Acrid lemma. What is Acrid lemma says? What Acrid lemma says here? By using Acrid lemma, that says if we have three integers ABC such that A divides the product of remaining two, and GCD of one of them with A, either B with A or C with A, and GCD of A with, suppose A with B is equal to 1, then it must be that A divides the second number C. Acrid lemma says if we have a three integers ABC, A divides the product of the two, and GCD of A with any of them is equal to 1, then A must divide the remaining number, that is C here. So we can use this Acrid lemma for star. How? Star can be written as 2A into B. Now we have give reason here. GCD of B and D is equal to 1. So GCD of B and D is equal to 1 here. So we can use Acrid lemma here. So star implies in star we have three numbers. One is 2A, second is B, and third is D. Acrid lemma says that if we have three numbers, if the GCD of any of these two numbers with the divisor D is equal to 1, and we have proved this, GCD of B and D, this is equal to 1, then Acrid lemma says that D must divide the second number 2A. So star implies D must divide the second number 2A because GCD of B and D is equal to 1. I again repeat, Acrid lemma says that if we have a three integers, if the GCD of any integer which is in the product with the divisor is equal to 1, then it must be that the divisor must divide the second number. So we can use the Acrid lemma for star here. we have here three numbers 2a, b and d. Now GCD of d with b is equal to 1. So it must be that d divide the second number 2a. Again we can use the accurate lemma here. Again we have three numbers here 2a and d. 2 and a and d. Now it is, we have also proved GCD of a and d, this is equal to 1. This is equal to 1. It must be implies that by using accurate lemma d divides 2. Finally, as d is a positive integer and it divides 2, there are the only two positive divisor of 2. Either it is equal to 1 or it is equal to 2 here. So this completes the proof of its C part. Next we discuss its D part. I have done here a little mistake, so kindly ignore this. There is no condition of common divisor here, of common divisor of A and B in 20D part. There is only condition that GCD of A and B is equal to 1 and just C is the divisor of A and B. So there is no condition of, this is not necessary. That C must be a divisor of A and B. It is given only C divide the sum. Now you can safely use this result for our given question. GCD of A and B 1 and D divides A plus B from here. So this part says GCD of A with D and GCD of B with D is equal to 1. So there is this is not a condition that C divide A and B. So now discuss its D part. Okay, next we discuss its D part. We will use the same technique as we used in its C part. We suppose the GCD of these two numbers is D. Let GCD of A plus B and A square minus AB plus B square is equal to D. As D is the GCD, so D must divide the numbers A plus B and D divides the second number A square minus AB plus B square. If D divides A plus B, then D divides must be divided square also, A plus B whole square. Similarly, as we have done in previous part, we will consider its second part. D divides. Consider D divides A square minus AB plus B square. I want to complete its square of A and B, A plus B. This can be written as A plus B whole square minus 3AB by adding and subtracting 2AB. We have D divides A plus B square minus 3AB. This expression shows that D divides A plus B whole square, and this expression shows that D divides the difference. This implies, by using the same concept that we have discussed in its C part, we can say D divides its second number 3AB. If a number divides the difference of two integers and it is also given D divides the first integer, it must be that D divides the second integer also. So D must divide 3AB. This can be written as 3A into B. Say this is my star. Again you will give the reference of problem 2.3 question number 20D. That says, I am again repeating, that says if C is the divisor of A and B, A plus B, sorry. That problem says if GCD of A and B is equal to 1, C divide the sum of A and B, then GCD of A with C and GCD of B with C is equal to 1. I hope you can write all of these, and then again we will use the accurate lemma. Accurate lemma says that if we have three integers a, b, and c, if GCD of a and b is 1, then a must divide c. So I am using the accurate lemma here from star. By using accurate lemma, d divides the first number 3a, because you can give the reason. GCD of b and d is here equal to 1 by using this problem. Again, when we use accurate lemma here, this implies d divides c, because GCD of a and d is equal to 1. As d is a positive integer that divides 3, it is possible only when d is equal to 1 or 3, because there are the only two positive integers that divides 3 exactly. These are equal to 1 or 3, and it completes the proof. So inshallah, in the next lecture we will discuss question number 5, that is also related to properties of GCD. Inshallah, if you find this lecture is helpful, kindly like, share, and subscribe my channel. If you want to find any question, you can message me. Inshallah, I will reply you. See you in the next lecture. Take care. Allah Hafiz.